I'm very happy to open this session, sense of discussion about Qbism and Convivial Solipsism. And today, that will be a different format from the format we use in the standard way. That will be a round table between Fuchs, who is professor at the Massachusett University in Boston, and who is one of the main founders of Qbism. Michel Bitbol, who is directeur de recherche émérite of the Archives Husserl, and was intensively thought about Qbism and Convivial Solipsism, and has written a lot of things about that, and mainly in his last book, Philosophie quantique. And myself, I'm Hervé Zwirn. I'm associate researcher at the Laboratoire of Mathematics of École Normale Supérieure Paris-Saclay and at Institut d'Histoire et de Philosophie des Sciences. So I'm very, very happy to open this discussion because I think that Chris will not contradict me. All these works are progress in work in progress because we are not sure.
I won't contradict you.
You won't contradict me, I know that. And of course, we developed our own interpretation, Qbism for Chris, Convivial Solipsism for myself. But of course, the way we see our own interpretations have evolved during time and is still evolving. And that sort of discussion is very precious to compare the way we think about that, to see what are the main common points and the main differences. And it's very interesting to have with us Michel, which has a critical point of view from the outside and who is able to, let's say, say if this point is good or not, or the way he sees these points. And the discussion between all of us is very precious to have our own progression and our own reflection. So I'm very happy to open this session, and without any delay, I give the talk to Chris. Thank you, Chris.
So I am tasked with giving the fastest introduction to Qbism that I have ever given. I promised Hervé 10 minutes, and so let's go. Here's the key point. Qbism did not start with an epoche. Qbism didn't start with knowing anything about Husserl or any of the phenomenologists. Instead, Qbism took its guidance from Edwin T. James, who gave us the quantum mechanical formalism on a plate. So the starting point was not reminding myself that I know nothing about the world. The starting point was taking the formalism of quantum mechanics as given and letting James lead the way with the remark that the quantum formalism is a peculiar mixture of describing in part laws of nature, in part incomplete human information about nature, all scrambled up together by Heisenberg and Bohr into an omelet that no one has seen how to unscramble. Yet we think the unscrambling is a prerequisite for any further advance in basic physical theory. Carlton Caves, Rudiger Schack, and I took that very seriously in the early 90s, and then by the time of about 2000, we had decided that the best way to unscramble the omelet was to hold fast to a subjective notion of probability, and then to look into quantum theory and ask, what must it be so that the probabilities still come out to be subjective probabilities, despite the seeming appearance of there being an underlying statement about the way the world is. So we took the point of view that quantum probabilities were Bayesian probabilities, but then we noticed various holes in that paper, and it's a shame that the paper is still cited over and over and over as the founding of Qbism, when indeed it was not. Consistency required us to go a lot further than we had ever gone before. In particular, we were led down a path from James's notion of probability to the notion of probability of Bruno Di Finetti, who said that probability does not exist. What he meant by that is that probabilities are never factual features of nature. They are not statements that can be true or false. The implication of that idea is profound because if one has a sufficiently rich set of observables, one can reduce quantum states to nothing but probability statements. Quantum states are equivalent to probability statements. So if probabilities cannot exist, do not exist, then it was the case that quantum states do not exist either. Quantum states are not factual in nature. This drive for consistency, though, made one after another term in quantum theory fall. If quantum states were subjective degrees of belief, just like probabilities, so we have established, or we were required to take quantum states as subjective degrees of belief, but then it fell to the features that describe measuring devices. They, too, if one looks at the formalism, one sees that these operators are in fact of no distinct character from these operators. If these are quantum states, if these are density operators, if you renormalize these are density operators. And when you change quantum states during a collapse, and you look at the general rules for collapses, then you can prove that they too are mathematically identical to quantum states on a larger system. And that holds for even unitary evolutions. So term after term after term of quantum theory became recognized as having the same character as a quantum state. The implications of this, now the second time I'll say it, are profound because this blocked our viewing. For instance, in the Paris and Fuchs paper, we viewed measuring devices basically in the way that Bohr did. But by the time we'd gotten to this stage of thinking, we could no longer align ourselves with Bohr. A quantum measurement device was now a subjective degree of belief in the same way. So if a measuring device is not something classical and solid and hard out there, what are we left with? Well, one thing that we were left with that we didn't know it at the time was this quote of Oliver Holmes, who said, "I describe myself as a betabilitarian. I believe that we can bet on the behavior of the universe, bet on the behavior of the universe in its contact with us." In other words, we had to take the hard left turn that quantum measurement outcomes just are lived experience. There's no intermediary like a quantum measuring device along the lines of Bohr. Still, not everything about quantum mechanics is first personal. Phenomenologists do not like to hear this because they want the world to be nothing but first personal. Well, at least I'm going to hold up the position that quantum mechanics is not all first personal. Measurement outcomes or lived experience. Measurement outcomes are first personal. But there's more to quantum mechanics than that. Particularly, there is the whole reason we use quantum mechanics from the point of view of Qbism. We use quantum mechanics because it is an addition to making better decisions as we try to flow through life. Leonard Savage had a book titled How to Gamble If You Must, and we append that only by saying it's how to gamble if you must in a participatory universe. Now, a very simple way to see what the upshot of all of this is to modify Feynman's lecture on the double slit experiment using some tools from quantum information theory called informationally complete measurements. And one can see that there is a way of writing the Born rule. The Born rule represents the probabilities for the measurement outcomes of such a measurement. You can rewrite it in terms of the probabilities for measurement outcomes of other measurements in a distinct experiment. So there is a general way of thinking of the Born rule as nothing but a way of combining probabilities. So here we have probabilities. Probability assignments from the point of view of Qbism are always first personal. There is the probability of the measurement outcome in one experiment written in terms of the probabilities of measurement outcomes in other counterfactual experiments. And the normative reading of this rule is that an agent should try their best to make sure their probabilities fit according to this rule. Now, their probabilities may naturally fit according to this rule because the probabilities perhaps are reflective of previous experience. But in general, they won't be. And it will require a new ingredient, one that William James called the will, to make these numbers fit. So we have an equation that has three terms, each of which is first person. But not everything is first personal. It's the relation itself that's third personal. It's invariant. I might use it, Hervé might use it, Michel would use it if he were doing quantum mechanics. Each of our subjective ascriptions for each of these terms may be different, but we will all use the same rule. It's the invariant piece of what's going on. So, for Qbism, in essence, the Born rule is the essence of quantum mechanics, and the fact that it's not the law of total probability as given to us by Bruno Definetti, but rather something else. The minimal difference between those two expressions is what Qbism is effectively the H-bar in our view. That's my fastest ever introduction to Qbism.
Thank you. So, let me switch to Convivial Solipsism, and let me just explain where does Convivial Solipsism come, and the reason why I have developed it from an initial remark from Bernard Espagna. The very beginning of Convivial Solipsism was after Bernard Espagna remark about the fact that he was totally unsatisfied by Everett's interpretation because he was not at all willing to accept this infinite number of worlds. And the goal was to try to find a way to describe quantum mechanics without any reduction postulate, but without also any multiplications of world and observators. So for Convivial Solipsism, as in the Everett interpretation, there is no reduction, and the physical universe remains in a superposed state. I will explain just later what that means, because I know that Michel is trying to tackle me on this point. So I will explain that just after that, because there are two ways to present that. But there is only one universe, one world, and one observer, in contradiction with Everett. So the question is, if you have this superposed wave function, entangled wave function. I just explain what it is. S is the system, A is the apparatus, E is the environment, and O is the observer. So at the beginning you have a system which is in superposition, sigma, Ci, Phi, and the apparatus, the environment, and the observer is in a steady state. Then after the interaction, and following the unitary interaction, you have an entanglement, and all the systems are entangled, and you have a global wave function, which is this superposed wave function. So for Everett, this superposed wave function can be used to explain the perception of each observer, because the world is splitting is as many different worlds that you have possible results, and this is also the case for the observers. And the question is, using this entangled wave function, how is it possible to perceive only one result? And that was the very beginning of the work, is to try to explain what there is only one result. The idea is very simple. It's the idea that our brain does not allow us to perceive directly superposed states. When we look at the superposed state, we perceive only one component of the superposition. So there is no need to have many worlds and many observers. One observer has limitation in his brain and is able to see only one component of the superposition. And I like to give this picture of a spinning dancer. And when I have time, I make a poll, and I ask the room, how many of you are seeing the dancer spinning clockwise, and how many of you are seeing the dancer cleaning counterclockwise? And usually half of the room is seeing the spinning dancer in one sense, and the other half is in the other sense. And I must even say that with a little bit of training and a little bit of headache also, it's possible to reverse the sense you see the spinning dancer. Okay, so what can, of course it's a very limited analogy, but what it is possible to learn about that is that when you see something and which is an ambiguous picture, then your brain make a selection at random, and then you see either one sense or the other. And I want to use this analogy to say that it's the same with superposed state. When you have a look at a superposed state, then your brain is not able to see the superposition, and your brain selects one of the components, as here you select one sense for seeing the spinning dancer. Okay, so a measurement in convivial solipsism is nothing but the perception of one component of the entangled wave function. And what I call the hanging on mechanism, the perception of the observer is hung on to only one branch of the superposition, which is chosen at random according to the bound rule. And that is also a possibility to solve the problem of probabilities that is pregnant in every interpretation. And a measurement is nothing else than the fact that we look at the superposed states and we select, well, in the preferred basis, because we have, of course, the question, as in the Hervé interpretation, of knowing in which basis you write the superposition. But I use decoherence for that, as it is possible today to use decoherence to answer the question that could be asked to Everett also. You have the preferred basis, and you select only one component of the superposition in the preferred basis. Nothing physical happens in a measurement. And that solves, of course, the measurement problem, because as everybody knows, the measurement problem comes from the fact that there is a competition between the unitary evolution and the postulant of reduction, and there is no clear way to define what a measurement is. In convivial solipsism, things are very clear. Nothing physical happens, and it's only when you are mentioning the perception of the observer that you have a measurement. Important points to understand all the consequences, of course, we'll discuss after that, and I have no time here to list all the consequences of the hypothesis. But an observer has to be treated by another observer exactly as a potential measurement apparatus. This is the same in Qbism. It's often said quantum mechanics is a universal theory, and except for the observer himself, it applies to everything, including other observers. And the other point is that an observer has no direct access to another observer's perception, and that means that when Alice, for example, makes a measurement, that is not a measurement for Bob, till Bob asks Alice which result she got. And it is at this time that Bob, making a measurement on Alice, gets a result for the measurement if Alice has previously made a measurement on the system. That's a very important point, because that means that the reality and the results are shared convivially. That's the reason why the name is Convivial Solipsism. They are always in agreement, but that doesn't mean that for a super observer who has access to all the perceptions, they really have seen the same thing. And that's an important point that is often misunderstood by people reading Convivial Solipsism. So two principles. The first one is the hanging on mechanism, which I just described. And the second one is the relativity of states, and that's similar to Qbism and relational interpretation. Everything is relative to one observer. There is nothing absolute. And that goes in the same direction that recent results on the many papers on the extended Wigner friends, showing that it seems that if you take quantum mechanics seriously, and that you consider that it's a universal theory, then it's very difficult to maintain the fact that there are absolute facts. Facts are relative to observers. Okay, so I finish by the presentation of the ontology. There are two levels for the reality. The first one is what I call the empirical reality, which is the potentialities of all the observer could actualize and which is described by the entangled wave function. And the second level is the phenomenal reality, which is built from the results that the observer gets by making measurement on the empirical reality. And the question is, and I recognize, and that's a criticism from Michel, that I have not always been clear about that, essentially because for publishing in physics paper, you have to adopt, mitigate ways to say the things, and if you are obviously not realist, you are often blocked by the referees. So I presented that as if the empirical reality was a sort of a vague reality à la Bernard d'Espagna. But there is a second way to present that which is much more close to phenomenology, which is to say that empirical reality is just a tool which has no existence in fact, and that the quantum formalism is a tool for predicting what is happening in the phenomenal reality and not more. And I think that we are going to discuss that after Michel's criticism.
Good.
Thank you.
My talk is about a comparison between convivial and solipsism on the basis of a difference that is typical of phenomenology between naturalism and transcendental stance. And I think this, cut between two categories of interpretations is rarely done. To do that, I started from a classification of interpretations by Matt Leifer and modified by Hervé, and a characterization of a class of interpretation called by Leifer the Copenhagenish interpretations of Qbism, of quantum mechanics. In fact, this class of interpretations encompasses both Qbism and Convivial Solipsism and many more. So these are the four characteristics that are supposed to pertain to all the Copenhagenish interpretations. But I think there are some mistakes in this characterization. For instance, there is no proper distinction between epistemic and doxastic views of the state vector. Epistemic just means that you don't know something, and that the quantum state is just an expression of this lack of knowledge. Instead, doxastic means belief, what you believe about what will appear in a certain experiment. This is quite different because that doesn't mean that there is something in the world that is going on and that you ignore. It's just that you believe that something will happen as a reaction to your action in the world. Another point is that, as you see, here on the third point, it is said that in this class of interpretation, quantum theory is universal. This is right. It applies to every system, whatever its size. That's right also. But then it is said, in particular, observers can be described by quantum theory. That means that, in fact, you believe that in these Copenhagenish interpretations, the quantum state gives a description of something. And this is exactly what Jaynes denounced as the omelette. Namely, there is part of prediction and part of description, part of epistemic and part of ontic. And if you correct that, you should say observers can be the target of the predictive rules of quantum theory rather than of the description by quantum theory. And the same here. Quantum theory is complete. You should not say complete without any precision. You should say that it is predictively complete in this class of interpretation. Whether it is ontically complete or not is completely out of the scope of such interpretations. Now, among the available interpretations of quantum mechanics, there has been a distinction made precisely by Leifer and Hervé between the objective and the perspectival class of Copenhagenish interpretations. Objective means that one believes that there is a unique objective experimental outcome, and perspectival means something like relative facts, namely facts depend on the perspective. But I think I could make another completely different distinction between two subclasses of this class of Copenhagenish interpretation. The ones that are naturalistic and the ones that are transcendental. What does it mean? What does it mean? Well, naturalism means that, when you believe in naturalism, that means that you believe that everything relevant to physics is part of an objectified nature, including the conditions for studying nature. Namely, what is a condition for studying nature? It is that you have an experience of it. It is that there is a subject who can study nature, and so on and so on. This is the condition for studying nature, and naturalists believe that even the condition for studying nature is part of nature. In fact, that means that you adopt a God's eye standpoint, that you become completely independent of the process, and you see everything, both nature and subjects, as part of a bigger nature, so to speak. Transcendentalism means something quite different, right the opposite, because it means that the conditions for studying nature are conventionally relegated in the background of nature. You don't believe that they are part of nature. They are just, as Kant would say, the conditions of possibility for studying nature. They fall under the heading of meta-theory rather than theory, and they belong to what one would call not God's eye standpoint, but rather limited, finite, situated standpoint. So this is quite different. And I think that relational quantum mechanics and convivial solipsism, and we'll come on that later, all belong to the naturalized versions of interpretations of quantum mechanics, whereas Qbism rather comes under the heading of transcendentalism, because Qbism relegates the agent, her experience, and so on in the background. It is not an object of the theory, it is the primitive term. They are the primitive terms. And other cases, for instance, there is the case of Einstein in 1905 when he formulated his special relativity, because he relegated rulers and clocks, namely the measurement apparatuses, in the background and treated them as meta-theoretical rather than objects of the theory. The same for Bohr, of course, for measurement apparatuses. Now, the problem is that naturalism is submitted to a famous paradox of the theory of knowledge, which is called the Munchausen trilemma. Namely, it can be, circular, or trigger an infinite regress, or posit an unseen foundation. An example is relational quantum mechanics, the interpretation of Carlo Rovelli, because you can have circularity, and you can have infinite regress, and you can have foundationalism. The three positions are found. The three defects are found in relational quantum mechanics. For instance, when Carlo Rovelli says, events or physical facts are realized in interactions between any two physical systems and are relative to these systems. Namely, so he posits physical systems and then says there is a relation between physical systems. But then he says, it's not the things or systems that can enter into a mutual relation, but it is the relation that gives rise to this notion of thing or system. So you have circularity. What is primitive? System or relation? Infinite regress comes here because you can say comparisons are only relative to a system. It is meaningless to compare events relative to different systems, unless this is done relative to a possibly third system. So in order to compare two systems, you have to have a third system. But in order to compare the two first systems and the third system, you have to have a fourth system, and so on and so on. Infinite regress, here again. Foundationalism, because even though Rovelli would not say that systems are realities, relations are realities. You know, reality is relation, says Rovelli. So not everything is relative, since relation is not relative. Relation is an absolute given. My criticism to Hervé's convivial solipsism is precisely that he tends towards naturalism, and he loves the God's high standpoint. For instance, when he says that the reason for supplementing Everett's interpretation with the mechanics of hanging up, I said hanging up, but I think it's hanging on.
It's hanging on.
Yeah. So read hanging on, please. It's that because you want to recover the concept of event, the event, for instance, of hanging on to a branch, thus affording something about which a probability is formulated. But you have no need of a theoretical concept of event. Events, just as agents, are meta-theoretical primitives. You don't need them to be part of the theory. So I think for that reason, the mechanism of hanging on is not absolutely necessary. Okay, first. Secondly, the consciousness capable of hanging on to one or another term of the quantum superposition must not be a physical system. If not, you have, if consciousness were a physical system, then it would fall under the description of quantum superpositions, and then you would have a superposition of consciousness, which you don't want. So, however, Hervé tries to specify a neurocognitive mechanism of hanging up, what he has presented to us, coarse-grained filtering of information by the brain. But then, if the brain is involved, and the brain is a natural physical system, then it should enter into the description of a quantum superposition, and then there is a problem in this case, because the work of selecting one branch, according to me, is not properly done. But we'll have to discuss on that. Another point is what I take to be an ambiguous status of state vectors in Hervé's presentation. Because on the one hand, and this I fully accept, the state vector unfolds by means of the terms or branches of its superposition, nothing else than the conscious observer's empirical world. Namely, the psi unfolds the domain of the observer's possible experiences. So you can accept that. You can accept that the state vectors just gives a list of all the possible experiences you could have if you made a measurement and an observation of the result. So that's fine. So psi is just a list of potential experiences, nothing more. But then he says, in other papers and other passages, the reduction of the state is only a way of describing what appears to the observer and doesn't concern the reality that remains superimposed. So that means that here the superposition, which is the way you write the state vector, so to speak, expresses reality. So here you have a realist reading of the state vector. And also this quote, the system remains in an entangled state, so it is the system that is in an entangled state with the device and the environment, but the observer's mind can only perceive one result. So here again, the system, the real system, the physical system is in a superposition as the quantum state describes, but not the mind of the observer, which means that the state looks to be more than just a list of possible experiences. By contrast, in Qbism, and here I quote Chris, the fundamental primitive of Qbism is the concept of experience. According to Qbism, quantum mechanics is a theory that any agent, and here agent is also primitive, can use to evaluate his expectations for the content of his personal experience. So, agent and experience are primitives. They are out of the theoretical picture, and therefore I think this is a typically transcendental presentation of quantum mechanics. Another quote: "A quantum state," says Chris, "is an agent's personal judgment. It serves to tie together all her probability assignments to the outcomes of all measurement actions she might take." So here again, the status of the quantum state is clear. It's all completely on the side of the possibility of betting of an agent about her future personal experiences. And therefore, to me, this presentation, Qbism, completely unscrambles the Jane's omelette. The Born rule can be viewed as a normative constraint. This is another point, actually. How realism re-enters Qbism. The way realism re-enters Qbism is not the same as, obviously, one who would say that quantum state somehow describes reality, but rather, and this was well expounded by Chris, but rather that reality is not represented, it is not representable, but it imposes emergent constraints on the rules of predicting the reactions that the environment is presenting to our actions. And there is a reply by Hervé to my criticism, actually. And it is clearly interesting because now there are two presentations of Convivial Solipsism. Presentation one, maybe the order of the presentations can be reverted. In the presentation one, you can accept that in fact this becomes almost like a transcendental presentation, because according to Hervé, the starting point is the something which gives rise to structures capable of perception, the observers. So the field of perceptual possibilities of each observer is what we call her empirical reality. So here, again, we have a clarification of what quantum states mean. Only phenomenal reality has the status of a kind of reality in that it is what the observer perceives and believes to be her reality. So there is a distinction between reality and the possible source of this reality. But the source of this reality is pushed once again in another way outside the quantum symbolism. I will not comment on presentation 2 because I have already presented it. It is a more mixed up presentation in which you have elements of realist acceptation of quantum states and elements of more empiricist interpretation of quantum states. So I think Hervé is progressively clarifying his position, which is very precious. But I think that I still have doubt. For instance, in presentation 1, namely the proper phenomenological or transcendental presentation, what about the hanging on mechanism of a personal consciousness? Because after the epoche, which is the thing that you normally perform to reach this kind of interpretation, isn't consciousness roaming everywhere, impersonally, as a radical precondition of any scientific inquiry, rather than becoming, I would say, a character of the play, rather than becoming an element of the theoretical description? Really push that outside. Consciousness is where we are. It is not something that we can put into play or describe or, things like that. So I think this idea of a consciousness which is completely out of the play, which is in fact a condition of possibility of everything, which is everywhere without being touched upon by theory, by physicists, I think is better expressed by Qbism, by its very silence about that.
We can start the discussion, perhaps. Forgive me, Chris, I'm just willing to answer to 2 points, and then you can say what you think. Okay?
I've already
said
it. I've already said it all.
Okay.
There's nothing more to say.
Okay.
I'm done.
Yes.
Okay. I think that I have two different things to say. The first one is about Convivial Solipsism and your criticism and comments, and the second one is about Qbism.
Yes.
Okay. Perhaps it will be simpler if I start by Qbism. And this is a discussion that we had many times with in the previous time with Chris. And it seems that Cubists have evolved about this point, is the question of the agent. You say, as Chris was saying at the very beginning of Qbism, that there is no need to define what an agent is. Okay, I always criticize that because it's totally different in the case of the classical calculus of probability. Once you have made a conference here and you came with the Savage book, I remember that. Okay, and you put the book on the table and you said there is no need to define an agent. Because there is no need to define what is the mathematician that is using the probability calculus if you want to compute something. Okay, I am in total disagreement with that.
You disagree.
I disagree totally for one reason. In the classical probability calculus, you are totally external to the events that happen. If you want to compute the probability that tomorrow it will rain, or on which face die is ending is whirling, you just witness what happens independently of you. While in Qbism, and that's very clear, in all Chris papers, you create the result. Without agent, there is no result. So it's not possible to say that the agent is external, because the agent is the reason why, or is part of the reason why there is a result, because it's the interaction between the agent and the action he is doing on the external world, whatever the status of the external world, that is creating the result. So you can say the agent is external and I just have to so that's one point. And it seems, and let me if I'm wrong, tell me if I'm wrong, Grace, but Jacques Pienard, and you sent me the video, himself made a conference saying that it was wrong at the beginning of Qbism to say that it was not useful to define an agent, and that it is necessary to define the agent inside Qbism, and he made a whole conference on this subject, and I appreciated that. So that's one point, and I think that Chris will want to answer.
But I have
okay, so let's speak about that, and then we'll come back to the other point.
Because
okay?
I agree that you cannot say that the agent is completely external, of course, to measurement. Yet there is a difference between saying that in a meta-theoretical language and saying that the agent is part of what the theory either describes or predicts. This is completely different.
Yeah.
So what I say is not that the agent should not be characterized somehow in meta-theoretical language. Even saying the word agent is already saying something about it, because that means that it is not just an observer. And
a passive observer.
It's not a
because
passive
observer doesn't mean passive. In console, observer is not passive, it's active.
A passive observer. It's an active agent.
Yeah.
Okay. So this is a characterization of the agent. But this characterization is not meant to become part of the theory, Because if you make it part of the theory, then you land into all the paradoxes of naturalism that are exposed. You become either circular or Frandeschennis and so on. So
I can agree with that. I agree.
That's only
I agree. I agree. You're right. I agree with that. I just want to precise, and I just would like what Chris is thinking about that.
Yeah.
I agree on this point, but you need, at the meta-theoretical level, to define what you can consider as an agent.
Mm-hmm.
I don't mean that you have to include the agent in the description, the level of the theory. But at the meta-theoretical level, you need to define what you can consider as an agent.
Mm-hmm.
And that was essentially my point. And you're right, you have the difference to make between the two levels. I totally agree with that.
Okay.
So what is your feeling, Chris?
In English, I don't know if there is in French, there's a phrase called that says the pot calls the kettle black. Do you guys have something like that? So, the pot on the stove is black, but the kettle is black. So, Hervé says, we must define what an agent is. Yet, when I turn to him and say, what is the hanging on mechanism? Tell me what it is in detail. Oh, well, it's just that neurological reasons have it so that an agent hangs on to the branch of the wave function and never lets go, like a blood-sucking entity. Anyway, this is the pot calling the kettle black. If I am guilty, he is guilty. If he is guilty, I am guilty. So that is only one remark. I have never felt the force of what Hervé feels so strongly. Probability theory can be used for all sorts of things. There was never a requirement in Savage's book that the events were completely independent of an agent. For instance, one might use decision theory or use Savage's techniques for deciding whether it is in one's best interest to make a proposal of marriage. Now, this is certainly making the proposal helps create the outcome. One can use the tools of probability theory there, just as one can about the weather, etc. Maybe it becomes more complicated in its analysis, but I don't see a point of principle. Finally, one remark. Jacques Pinard did not say Qbism made a mistake in that video. If he had said that, he would not be my postdoc. What he did say was that Qbism can be understood as two projects. One part of the project is to understand quantum theory as a decision theory in lines with, say, Savage's development. And for that, one does not need to give an explicit account of what an agent is. Then, on the other hand, Qbism has greater aspirations than just seeing the formalism as a decision theory. It has further aspirations to see what does it mean to say a measurement outcome equals lived experience, and give a more detailed account of that, and to ask whether the formalism, the particular way that quantum theory sees measurement outcomes with the particular structure of them, could this inform the very notion of experience? Could it tell us something about the particularities of experience in the world? And there, Pinard claims that one needs a more detailed account of what means an agent. But so there are two things. Now, when you and I had our first conversation in Lettres, many years ago, I had not yet drawn these distinctions between the decision theoretic project and the ontological project so well. And in my mind, I'm always thinking of the decision theoretic project, and I stand my ground. Phrase pot calling the kettle black.
Okay, we can say that we converge on this vision.
Oh.
Okay, yeah. So perhaps I could, unless you want to precise things about agent, or is it okay? Perhaps I would like to try to answer to your criticism about the two versions of convivial solipsism. I would say that it's difficult because it depends on which people you have in front of you. Convivial solipsism, and that's also the case for Qbism, are interpretations that are very frequently repulsive for people. When you present that in a conference or in a paper, the vast majority of physicists you have in front of you are strong realists. And as soon as you defend something that is not relying on the strong realism, standard realism, from the beginning, they are not open to listen to you, and they want to destroy. And the name, that's a bad name. Now I regret to have chosen convivial solipsism.
Then change it.
It's difficult after 20 years. It's difficult. But you have been accused of solipsism, and that you don't like that at all, because neither Qbism nor convivial solipsism are solipsism. But that's my fault. I should have. I was provocative at the time, and I found that funny, but it's not. Okay. So the question is, how are you going to present your interpretation? And then you have to present things in two different ways. If you are in front of philosophers, you can try to abstract things and say, okay, the only reality is the phenomenal reality, and the quantum formalism is only a tool that you can use for predicting what is going to happen in this phenomenal reality, and the empirical reality is a sort of way to speak, but there is no real existence of it. And that's, of course, the version that you prefer.
Yes.
Okay. If I say that, I know that it's already very difficult. I know that I will be blocked when I want to publish a paper in physical journals. So I choose to present that in a more realistic way. And that was not so far from what Bernard Espagna was saying. And I know because, well, I had the opportunity to discuss that with him before his death. And I know that he was open to the presentation with the empirical reality being something real, veiled but real. And he would not have liked the second presentation. So I use this presentation that is based on something that is more realist, and the empirical reality is something that we have not direct access, but this is something where you are putting some probes to have something emerging, which is your phenomenal reality. And I perfectly understand that you are not satisfied with that, because that's a sort of naturalist version.
A little bit naturalist and a little bit like the omelette of chains. You know.
That's true. I confess that. I agree. That's true. I agree with that.
A short answer. The problem of presenting such interpretations to physicists, and especially realist physicists, is really acute. I agree with you. But my personal strategy has been to be completely candid about that, namely just throw directly my own convictions about the primacy of lived experience and so on, and then see what happens with them. And I tried then that strategy in a short workshop, which was held somewhere in Germany, and in which there were only supporters of Bohm's interpretation, so the most possible, the best possible realist interpreters of quantum mechanics. They were all supporters of Bohm, except for me, obviously. And I exposed, and I must say, I exposed my views about the first person experience, the fact that the psi function, like Chris, only expresses our disposition to bet or our disposition to fix probabilities and so on. And there was something that happened, namely everyone was discussing of that, because their views about Bohm's interpretations were certainly very interesting, but they were not divergent enough to trigger discussion. Whereas the difference between the first-person interpretation and the realist interpretation was something that was worth discussing. So I think that trying to present these views without any attempt to disguise them is not a bad thing after all.
Chris, do you want to answer, or should we switch to the question?
Well, just briefly, I have some sympathy to what you say, because I have understood personally since around 2003 that the word knowledge or information was inappropriate for quantum states, in my view, but rather beliefs or gambling commitment was the right term. But when you give a talk in front of physicists, especially aggressive physicists or some aggressive philosophers of physics from Rutgers, who I won't name, now at New York University. I won't name them. But anyway, if you give a talk in front of the wrong person and you choose the wrong word, they will interrupt you so much that you cannot get the gist of your point out. So for quite some time after 2003, even though in my heart I thought quantum states are states of belief, when I would give a presentation, I would say knowledge, just to placate them, to shut them up enough so that I could get more presentation out. But in my papers, I've always been consistent. As I develop my view, then I try to stay consistent to the new view, always in the paper, because nobody can push you off the stage with your paper. So I have some sympathy, but not complete sympathy. But also, you think you're making yourself sound more like a physicist by introducing the universal wave function. Go to Vienna in front of Zeilinger's group and tell them, look, here's the universal wave function. They'll kick you out just as much as... So, you know, it depends.
It depends. And it depends if it's a conference. And in this case, if you are ready to debate, even hardly, and I like that, so it's okay. But when you submit a paper to a review, you can't debate because the referee is just rejected. And you have no way to discuss. Yeah. So you have to be prudent if you want to be published, otherwise you are not published. Depending on the paper, of course. And you have often published in philosophical review.
That's right. Yes.
And that's the good place.
That's right.
Yeah,
I understand.
Okay. So any question, Alexei?
Yes. Maybe we should start with a question for Chris. By the way, a remark, in Romance languages, proper names that start with MAU usually mean bad something. You can use that for your friend at NYU.
MAU. Oh.
Yeah.
But we won't name.
No. So here's the question. Under the epoche, you have the agent, and remember Savage's book says how to gamble if you must. What exactly makes you think that the agent, especially under the epoche, must gamble with probabilities, let alone quantum probabilities? Maybe the agent under the epoche wants to do entropy, measure uncertainty. Why probabilities under the epoche, right? Not because we know the story of quantum theory, but why is that guy under the epoche driven into gambling or betting rather than assessing, evaluating uncertainty in some way using, let's say, entropy? You can do full quantum theory with entropic Bell inequalities, lots of stuff. But what drives you into probabilities? So that is the first question for Chris. Maybe.
Can everybody see the spider?
It's a spider.
It's going up.
Wonderful.
It's trying to escape us.
Oh yeah. Probably.
Savage's book was about how to make decisions. So I kind of cheated. I showed the cover of one book, and then I used the title from another book, and the other book was How to Gamble If You Must. What he wanted to develop was a theory of making decisions. And so he started off with a set of axioms for, well, if I take this action, what are the possible results, etc. If I take this action, what are the possible results of it, and so forth. And then he imagined that one might have a preference ordering for, I would really prefer for this to happen, but I really can't assure whether it will. Second to that, I prefer that this other thing happen, and so forth. And then he takes this large framework and he tries to say, or he tries to argue, that the natural thing that comes out of a preference ordering is that one should try to maximize expected utility. So along the way, the notion of probability comes out and the notion of utility comes out, and it's just from the axiomatization about how to make a decision. Now you might ask, and I think this is what you're asking, is potentially an alternative axiomatization could lead to not probabilities but entropies at the outset. And I don't really have an answer for that so much. In other developments of probability theory, like that of Cox, he wasn't worried about making decisions so much as he wanted to establish a measure of plausibility. And he had some rules for what plausibilities, he didn't call them probabilities, what plausibilities should satisfy. And then he was able to, by solving some functional equations, to say that a plausibility must have the character of a function of, so he ended up with entropies as one possibility, ended up with probabilities as another, and then it was just an issue of one is a function.
You can also imagine in the way of Samson Abramsky, who would probably say, I want a possibilistic agent. It's either zero or non-zero, just a possibility, right? Binary, zero, non-zero, no 0-1 interval, just that. And you can imagine an agent like this. So the question would be, what drives you into this kind of agent, in this kind of mathematics under the epoche, rather than possibilistic or entropic or something else?
So maybe the shortest answer is simply this, that instead of starting with an epoche, as I said, I started with the quantum formalism.
Okay.
And the quantum formalism, that is the starting point for me. And then the Born rule gives probability. So that's the thing that we do.
Can I ask a question for Michel? Michel, of course, your use of the word naturalistic is very classic for philosophy of science. But I wonder whether you want to go a little further and ask what is nature under that account. On that account, what exactly is meant by nature? They mean external, so does it mean reality external to observer, or does it mean something else? Because, there is a notion in the history of philosophy, nature can mean many different things. It can mean an imprint, which makes it a little more transcendental, if nature is seen as an imprint of... it can mean growth, it can mean external reality, but then you have to be a realist in some way. So it can mean different things. If you classify solipsism as naturalism, you probably don't mean any form of realism. You probably mean that nature means something else, not an external reality. So maybe, to complexify your binary classification a little bit, which notion of nature applies there?
Thank you, Alexei. I think that the notion of nature that I selected was the one that Husserl used in order to criticize naturalism and to denounce what he called the crisis of the European sciences, you know. According to him, the main obstacle that is facing not only science but also our whole culture because of the choices of science is that we tend to focus our claim of existence onto an objectified nature, which is, it's not nature as a potentiality of manifesting. It's not nature as a process of production and so on. It's just an object that you are seeing from outside. And so if you naturalize the whole process of knowledge, as many people who deal with the theory of knowledge, and also many people who deal with the interpretation of quantum mechanics, that means that you include the subject within an objectified nature. For instance, you would say there is no subject, there is only a set of objects on the one side and a body with brain on the other side. So they are all objects. Everything is object. Objects of not only of language, but also object of physical theory. Namely, for instance, even the subject seen as just an organism with a brain will be said to be a potential object for instance, quantum theory. So everything is pushed outside, seen under a God's eye point of view, and treated as a potential object for physical theory. The most of universal physical theory of the moment, which in this case is quantum theory.
I agree with that, and I would say that you're right when you say that in the second, what you call the second presentation, which is the first one I gave. It can be understood as the empirical reality is something objectified because it's there.
Yeah.
And in this case, of course, that's not the usual way to understand the reality because it's not the same for everybody. Each observer has its own one and things like that. But the observer is inside it and everything is objectified, but in a way that is far. That's very close to vague reality of Paris-Saclay. And the only thing that is outside is that you cannot, and that's an objection that you make, you cannot describe the very process of perception in this thing.
Yeah.
And that is really something that could be defended. Of course, that's a departure for phenomenology. Yeah. But it's not easy to, that's a long debate, to attack that because it could be accepted as a sort of a medium position between phenomenology in the whole and standard realism. That's in the middle. And if you say that you don't have to explain, that's an answer to Chris, of course you don't have to explain the way the perception is working because we don't know. Okay. I agree that I'm not able to do that. But if you say that the only thing that is outside of quantum physics is not the mind, or the spirit, or the soul, and things like that, but only the way you perceive things. That's not something. That's the way we work. That's outside of the description of quantum mechanics. Then you objectify the world. And you have the second description of Convivial Solipsism. I know that you don't like it, but...
Yeah, okay, I understand what you say, and I understand that still you push something out of the picture, which is good according to me, because you can, like in a famous paper by Perez and Zwirn, in the paper called "Is Quantum Theory Universally Valid?" He showed that you cannot encompass everything unless you make other compromises on other clauses that are absolutely indispensable to science. So you cannot take everything within the scope of quantum theory. Yet What you exclude is up to you.
But Michel, yeah, it feels like, of course, I understand the use of nature in Crisis, in Husserl, but it feels like you want to make a sort of fine distinction between realism and naturalism in this sense, that you don't want to say that this objectification, which you call naturalism in the Husserlian sense, drives you into realism. So I think it would be helpful to have a very clear maybe example or distinction why this naturalism is not necessarily a realism. And that can be done. I think it's a point that needs to be appreciated here.
One possibility, for instance, one example would be Carlo Rovelli's relational interpretation, because you could say, okay, it's not realist in the sense that it doesn't say that systems pre-exist to their relations. It's not realist in the sense that you could say that there are relative states, not an absolute state. And yet, it is naturalist because you see everything under God's eye standpoint, including especially the network.
Yeah, I'm not sure whether Rovelli has an answer to what is part of nature. If you ask him what is nature in the relational interpretation, I'm not sure. Well, I had a question for Hervé, but maybe I should stop here.
I was a bit surprised by the presentation of Convivial Solipsism in the sense that it was very different from the one I heard for these reasons at the, say, Quantum Foundations conference about 3 years ago. And so, yes, I'm wondering to what extent, at what point we have to say things are just a completely different interpretation. Like, I understand that you evolve about the way you think about quantum mechanics, but at some point, for clarity, we have to know maybe it helps to change the name. Because last time that I heard about Convivial Solipsism, and I take the risk of not recollecting it perfectly, but it was hardcore realist in the sense that it was a sort of Wigner interpretation, except everyone is their own Wigner and cut and lives in his own universe where he's the only conscious being and everyone else is kind of a zombie in the consciousness literature. And then these people still exist and are conscious, but in another branch. So that there is no branch consistency. At least that's how I understood it then. And in this realist presentation, it is crazy but sharp. Okay, I understand very well what he said. I just find it completely crazy. In the new version, it's not obviously crazy, but I no longer really understand precisely what he said. But that's also because it was very short, so I'm not saying that this is either. But just it seems completely different. Like there is at a very fundamental level. About what it says about the world, and ultimately it seems that's what we are looking for, like a picture of the world. So first, is my recollection more or less correct? And don't you think that it would make sense to change this is a fairly different interpretation, and that's okay. A single person can come with several interpretations.
A single agent, because he's an agent, not an observer.
Actually, that's not different from what I presented 3 years ago, but due to the very short time I had here, perhaps I just not said everything I said in 1 hour presentation. That was the one I gave 3 years ago. And I wouldn't. What you describe as crazy, and of course that's crazy. Nobody can pretend that the description, the picture that it gives of the world is not crazy. But many things have been crazy in the story of physics. For people learning that for the first time. Well, we have a discussion with Frank recently, and because he thinks that it's crazy. And I said, okay, but when the first time people were told that the Earth is flat, that was crazy. When people were told the first time that there were no simultaneous events. It was crazy. So there are many things that have been considered as crazy in the history of physics. But that's another point. My version, Michel forced me to present two versions because of the criticism he made on the version that is more realist and that I used. But the basis is the same. Yes, each observer has his own reality. It's impossible to witness the fact that you don't have the same reality than me, because if we speak together, we'll always agree. So that's impossible to see that we are not in the same reality, because everything happens as if we were sharing the reality. That doesn't mean that you are a zombie, because you are exactly similar to me. You simply see things in a way that I cannot witness, and perhaps you see things differently than me. I am just going to give an example that Michel doesn't like because it's too realist, but let me just explain that in 2 words. Assume that you see a movie in color, and that I give you green glasses, and I see the movie with blue glasses. Then you are both seeing the same movie, but you'll see it in green, and I'll see it in blue. We will not see the same thing. That doesn't mean that you don't see a movie and that you are not existing. And that's a little bit the same. That's a limited picture. But what you heard 3 years ago is the same today. We live in our own reality, but everybody has his own reality, and that doesn't mean that you are a zombie. You have your own reality. I'm just not sure that it's the same than mine.
A bit more confused even, I would say. But the problem is that this, I thought that we understood 3 years ago that these realities for different can be macroscopically wildly different after a while. So this is what I would find crazy, and what I would say that the Hervé Zwirn I see in my world that my consciousness has access to is very different from the Hervé Zwirn that is actually conscious. Maybe in another room, maybe, like, this is all widely different. That's why I say it's not, okay, my problem is not about crazy. I understand totally that a level of craziness is required by quantum mechanics. I would just like the craziness be at the lowest level necessary, and this seems a bit like free craziness added on top of the minimal required.
Let just think about Everett interpretation. That's in this respect. That's similar to Everett interpretation, but in Everett interpretation, every different branches are coexisting for everybody. For us.
I had a question actually for both Chris and Hervé about your interpretations. So my question basically is, it seems to me that both of your interpretations seem to rely on the idea of either consciousness or an agent. And so I was wondering, couldn't you challenge that by saying that at least some part of physics need to relate to what happened to objects, like like a table or a glass, and not to humans? Just to take an example, if you take the creation of chemical elements in the stars, there were no agents back then to humans, to witness that. And yet quantum mechanics seems to work in that case. So, yeah, so that's my question, basically.
Where does one start? It's not as if I haven't gotten this question for 30 years. But for 30 years, I always have to struggle to answer it, because the vocabulary and the vision that you're using for physics and the vocabulary and vision that I'm using for physics we haven't established a good translation. So I would put it, maybe I don't know what's the best way to put it, but I'd say, look, of course there was I would say this, I don't know if Michel would say this. But I would say, of course there was a universe before there was any physicist. And of course there was a universe before anyone had written down the Born rule. And of course there was a universe. So yes, things happen. Now the question is, are they happening because of quantum mechanics? Is quantum mechanics the underlying thing that makes the universe happen? That's one vision of what's going on. An alternative vision is, there is the world and we're in it. And we are now trying to do the best things that we can in this world. From that point of view, it's not that the world is working because of quantum mechanics. It's that the world is just given. In this, it has a kind of phenomenological aspect. The world is just given. We are immersed in it. We're like little amoebas trying to swim to the better parts of the universe. And we use the various means that we can use to do that. And one of them, in 1925, was a genius idea that Werner Heisenberg had. He was studying anharmonic oscillator, he added some indices on things. Max Born recognized that the equation, I'm sorry, I'm so fascinated by this spider. So in 1925 something happened. Now something different happened, and it is that we realized the usefulness of using wave functions for making our decisions. So, how do I talk to someone who thinks that quantum mechanics is what has made things happen and made the molecules work the way that they do, and someone who says, look, the world just is. You know, there's bumper stickers in the United States that say shit happens. You know, shit just happened, and we've got to make our best in this world, and for that we developed this calculus.
May I just ask something to you? Just my own answer to your question would be another question. How do you know now that the universe existed before human beings? No.
I will answer you.
Yes, please. Chris.
We cannot know. Simply, we cannot know. But being a pragmatist, I'd say, what is the most useful hypothesis?
Exactly.
And I think the most useful hypothesis is that there was something here.
Perfectly. But this answer, I perfectly accept, of course, Chris's answer, because it exactly points to the issue I was trying to bring you. It's that the way you know that the universe existed before us is by elaborating models that are basically bets on what you will find if you do more experiments. For instance, if you send the James Webb telescope and so on and so on. And this model is such that you need to make the hypothesis that there was no human being at that point, and that there was a long history, and that this history produced us as biological beings, and so on and so on. But the basic point is that you are now betting that there was a Big Bang, that there was, and so on and so on. But it's the best possible bet at present.
The problem in this, when we speak about that, is that it depends on the beliefs of the person that is asking the question. I perfectly understand what you say, Michel, and
no,
I
just ask you to suspend your belief, epoche. Suspend your belief and see how comes that you come to believe to this.
You're right. The objection, I don't make it, but that many people make, is that, okay, perhaps you make the hypothesis because that's the best bet that you can do, that the universe existed before you.
Yes.
Okay, but once you have made that, do you believe that it's true? And many people, when they make this bet, say, not only this is a bet, but I believe firmly in it, because that couldn't be other way.
Absolutely.
And the question is, should we believe or bet or not? And what you do in phenomenology is that you are able to say, okay, I just wait, I'm not sure, and people don't like that because they want to believe really on something.
A
And that's the problem.
phenomenologist also believes that the universe was born 30.8 billion years ago, but he knows that he believes that.
Yeah, okay.
Okay. That's the only difference.
But the question that is often asked, how do you know? Well, if you say that is the interaction between the agent or the observer that makes the result, how can you say that, for example, 10 billion years ago, a star is born? Okay, I would say perhaps differently. This is one way to answer the question, but I think that people could say, okay, but if I have any sort of proofs that make me believe or betting that this star or this galaxy is born 10 billion years ago, that's true. Okay.
Yeah. But you know, if you accept that in fact it's only a belief, then you are much more flexible about the evolutions of science. For instance, you can suddenly discover that the Big Bang was not 30.8 billion years ago. You can suddenly discover that, in fact, it's not a good model to say that it was a singularity. Maybe it was something else, as in Hertog's and Hawking's model. You know, so many things can happen, or that there are black holes. Recently, some people say, no, all these things are not black holes, they are something else. So it's so, and the idea of phenomenologists is that your so-called knowledge of the past is suspended to the future of research. So there is no past other than your present and the future of research. Your present and the bets you are doing, nothing else.
I totally agree. You know that I'm sympathetic with this view.
Yeah.
But I'm just trying to defend the point of view of people that are not ready to accept that. And there are many. And we have to answer something to them. Because, of course, I agree with you, what you say. But I know from having discussed with many people that this is not satisfying for them. They don't like that.
Yes.
So, how trying to convince them of something? If you forget about what you say is a good answer. If you have to give another answer, something else, because people in front of you will say, I don't accept that. Okay, I have a proposal for this is another possibility to answer. Of course, that's not satisfying neither, because Antoine will say that it's crazy also. I would say in my second version, that is not phenomenologist, okay? I accept the existence as Qbist of an external world, independent of myself and of any observer. And this independent world is described by quantum mechanics. That is the entangled wave function. But I can't speak about events in this world, because that's entangled, that's not something we are used to. So the initial universe is described by this thing, okay? And when you say that this event, this astronomical event happened, then this is where you introduce your way of seeing a part of this huge mess. And then when we say, for example, that the Andromeda galaxy has been created, 5 billion years ago, that's not true in itself. That's just because you as a physicist, you apply your models on the data you have, and that you create for you this event 5 billion years ago. But 5 billion years ago, nothing happened. In fact, because there were nobody for that. And what happened at that time was just sort of a mix of everything. That's not very satisfying also, but
I understand.
but that is perhaps more acceptable for people absolutely willing that something is there.
In fact, it's closer to Wheeler's.
Yeah,
answer.
it's closer to Wheeler. Yeah,
Yeah.
yeah.
So my question was about convivial solipsism and the idea that the brain doesn't perceive superposition, if I understand correctly. So I guess the confusion I have, or the trouble I have about that is it seems to propose an interpretation of quantum mechanics that's based on the limitation, you could say, of our brain. But I mean, the brain is not a very good physical apparatus or detector, if you will, because I mean, if you take the brain, the speed of light is infinite, because we cannot perceive it's way too fast for our brain to perceive such a speed compared to the speed of sound, for instance. So, in the same way that I cannot just say because my brain cannot perceive events moving at the speed of light, why should I believe that the limitation of my brain concerning superposition is a good way to assess the physics? Because it would seem to me that precisely in the history of physics or science in general, the goal has been to construct instruments which are better than our senses. I don't know, like telescopes or microscopes. So what would you answer to that?
You have to take the question the reverse way. We have physics, and of course, when we want to make a measurement on a microscopic system, we have no access to it. So we have to use macroscopic apparatus. Okay? And if you take the unitary evolution seriously, then you are led to the conclusion that the macroscopic apparatus is entangled with the microsystem. What I say with the limitation of the brain is not that we have any access on the microscopic system. What I say is that if you have in front of you an entangled macroscopic apparatus, you are not able to see it in a superposition of macroscopic states. And that at this level, that the limitation of your brain prevents you to see the macroscopic entanglement or superposition. But of course, you need apparatuses for apprehending the microscopic world.
I don't see how that's an answer to the problem of measurement, because as you said, there is no mechanism. You have no mechanism to explain why we don't see the superposition right. So isn't that just switching from one mystery to another, basically?
You can't say that. I don't pretend to have resolved all the mysteries in physics. I just say that I have a proposition for solving in a coherent way the measurement problem, which is not the case for all the interpretations that I've pretended solving that. But as Michel noticed just before, there is still something that is outside. And what is outside is this filtering process that prevents us to see the superposition. And I don't pretend to explain that.
May I make a comment? I enjoyed your question because it gave me a whole new way to make fun of convivial solipsism. So as I understand Hervé's solution, if an instrument is too precise, then we just have unitary evolution. But if it is as complicated as the brain, then we have the latching on process, because the brain can't get a whole view of everything. But now, when you ask your question, is okay, so we can't have too precise of an instrument, one that we can define precisely. We won't get the latching on mechanism, we just get unitary evolution. But we apparently can't have our instruments, too imprecise, like a dog's brain, Can a dog collapse a wave function? No, it can't. Why?
Of course he can.
Oh, of course he can. An amoeba can an amoeba collapse
the
a wave
perception
function?
of a dog, I don't know that, of course. But there is something that the dog
it seems
perceives,
like you're
it's clear.
demanding a kind of sweet spot called humanity, and that's what it really boils down to. Your view,
What?
a sweet spot, a particular level. A mysterious level.
Not at all.
It's what this young man said.
Not
You're
absolutely
trading
not.
one mystery for another.
No, absolutely. I agree that I don't explain everything, and that this filtering process, I can't explain it in details. I agree that.
A filter can't be too good and it can't be too bad.
But I disagree totally on the fact that there is just that this is limited to human brain. Every system having perception has its own way to perceive things. And I think that, of course, a dog cannot use quantum mechanics, at least for the moment. But a dog has its own perceptions, and I don't know how a dog sees the world, but the reality for a dog is its own reality. It's probably very different from yours and mine. But a dog, and even, I don't know if fly has its own reality, I don't know that the limit, I don't know where to put the limit, but the famous problem, I don't pretend to solve it, of the level of consciousness that you need to have the perception of the world. But all the animals have also, and every alien in Mars or in any galaxy that you have, should have its own perception of the world with its own reality. That's not limited to human.
Let me just
race.
get this straight in a yes/no answer. A dog can latch on to a branch. Yes, no.
A dog can
latch on.
Latch on. What is latch on?
Isn't that your phrase?
No, it's a hang on.
Hang on.
Hang on.
A dog can hang on to.
Yeah, of course.
Okay.
Yeah, of course. Of course. Of course, it doesn't know what it does.
Exactly, that's the point. What does it mean for a dog to hang on to a branch? Nothing, because he doesn't have all the structure of quantum mechanics to know that he hangs on the branch.
But you don't need to know what you do for doing it. When you see something, you don't know what you do. You see it,
Yeah.
and for a dog, that's the same.
Yeah.
You don't need to know quantum mechanics to have perception. The hanging on is just the fact to perceive.
So
That's it. You don't need to know. Differently from Qbism, where the agent needs to have the knowledge of quantum mechanics. So a dog cannot be a cubist. But it's not possible. But a dog can perfectly fit in the Convivial Solipsism description because it doesn't need to know quantum mechanics.
That's right, but here again, that means that you are putting yourself outside the process.
Il y a une question. Bruno, oui Bruno.
This is very interesting, but the question of the dog is a dangerous slope because then you need to define what an animal is. There will be perception by bacteria and why not inanimate objects, trees, or even non-DNA based things. A rock will perceive some way. So
yeah, you're right. That's why I always answer. I don't want to exclude dogs from that because apparently it seems that dogs are capable of perceiving many things. But I don't want to enter into the discussion. That just to say that it's not limited to human race. But now I don't want to put a sort of frontier between man, dogs, cats, flies. I don't know. That's not a problem that I'm interested in. I just say that it's only for entities able to perceive. No, I don't want to make the list of perceiving entities.
no, but then it's not a matter of perception; it's a matter of consciousness because everything is able to perceive as soon as they have an interaction with the other beings, whatever they are, right?
Now, for example, differently from Carlo Rovelli's interpretation, a photon is not capable of perceiving, I think. A photon or an electron is not an observer, in opposite to what he says.
I'm not sure you can make such a easy difference between the pyramid from man, dog, bacteria, silicon, atom, nucleus, or electron, right? It's where to put the boundary.
Yeah. Okay. Okay. No, you're right. That's the reason why I don't want to enter into the discussion. That's a dangerous slope, as you say, and that's not the subject. The subject is it's not limited to human. But okay, so that's it.
I have maybe a comment on the discussion here, or I'll phrase it as a question, but maybe from another point of view. The gist of modal type interpretations to solve the measurement problem was that a superposition does not mean that the property that one property is not defined. There's a hidden assumption behind that. So one system can be in a superposition and have definite properties. And it seems to me like your interpretation, Hervé, is saying something of the same kind, but relating that to perception, that a system in a superposition is perceived to have one definite property and not being I don't know, fuzzy property or not defined properties. And the problem I see with that is that if you tie that to perception, which is gradual or in the like evolutionary trees of species and have different forms, then the question of to what the hanging on mechanism does arise, and I agree that's not a very interesting question to say, well, dogs can do that and mouse can't, say. So it's not a question that you want to answer, but tying this mechanism to perception, doesn't it mean that you'll have to treat this problem eventually because it's a gradual evolutionary function?
I could answer to this question about perception by being rigid. Okay, that's for human. Okay, I've replied. That's for human. I don't believe in this reply because I think that there are other things that are perceiving. But that's secondary. I'm not interested in knowing which kind of things are perceiving, dogs, cat, mice. I don't care. What I want to say is, okay, let's adopt the same kind of attitude that Qbism. Okay, quantum mechanics is for human, and what I say is available only for human perception. Okay, and the risk is that somebody will say, okay, but do you think that dogs are not perceiving anything? And I will answer, no, of course I think that dogs are perceiving. And I don't want to enter the discussion because I think that it's an interesting discussion, but that it's out of the scope we are discussing, that not related to quantum mechanics.
Okay, but you're adamant that it's the mechanism of the hanging on is related to perception, to function. Okay.
Yeah. But I'm very surprised because this hanging on mechanism is often criticized and people seem to say that you have to define that. The fact to say that our brain is not capable of perceiving everything in the world seems to me so obvious that I'm surprised that people are objecting about that. We don't see many things. It's not possible to see many things. No, you don't see electromagnetic waves. You need some apparatuses for that, doing that. And there are many, many, many things that we don't see directly. And when I say that the superposition is something that we don't see directly, it should not be more surprising than when we perfectly know that we cannot see electromagnetic wave or things like that. That's the same. And
I'm not sure. No. It's vastly different because if you speak of wavelengths, for example, well, in the framework of usual physics, you can explain that your eyes are the molecules in the retina are sensitive to pigments, blah blah, right? Wavelength. All this is consistent, right? The hanging on mechanism, you cannot explain it in a global framework by saying that your senses are not able to perceive, or you have to explain why the senses, the usual. you know, I like this question because I like to relate the intellectual constructions with our senses. I'm absolutely convinced that we're extremely dependent of the senses. We see in 2D, for example. This has shaped the way we make physics. Of course, if we would be able, for example, as you know, with artificial intelligence, we start being able to see much better in multiple dimensions. That with our senses, it's typically 2D, right? You have two eyes, we see a plane. Okay, so it's very different to say that our senses are limited because of the way they are made, from chemistry and physics, and the fact that the brain, specifically for some obscure reason, could not apprehend entangled waves, right? So it's completely different, I think.
That's not exactly the same. I agree. Could give another example, which is the colors. For example, birds see colors that we are not able to see, and that's not so easy to explain.
My sons are colorblind, so I'm very aware of the fact that they don't see the world the same way as we do. So of course, but well, this is obvious. But the fact that our senses are modeled the way we describe physics, this is certainly interesting, but it's not the core of this debate. The core of this debate is which kind of insufficiency, if you want, or limitation is making our brain select one branch of the wave function. That's still very much a mystery.
I have no answer to that. I must recognize that's something I cannot answer because I don't know yet. That's an hypothesis, and it seems to me that it's a reasonable hypothesis. But I cannot today, perhaps in 50 years, we'll understand much more the way the brain is working. I don't know. But today, that's true that I have no answer to that. I cannot give any precise mechanism for that.
I don't urge you to give a definite answer, but what you should not do is to compare this to the other limitation of our senses. I think it's a bad comparison. It's not valid. It's not valid, right?
Yeah, I agree. I agree with that. Okay. I'm sorry because the time is running, and I see that it's time to close the session. Thank you very much for all of you, all your questions, and people on Zoom, and Chris and Michel. And well, that was a very exciting and stimulating discussion. Thank you.
Thank you, Hervé.